Okay, so punch that in. Okay, we have our 24.31 plus 35.45 times 2. Okay, so we're looking at 95.21 grams per mole. Okay, and we're looking for little m. Okay, so n equals little m over big M. Anytime we're looking for little m, we've got to multiply both sides by big M. So we're going to have n times big M equals little m. So that'll be 95.21 times 8. Okay, because it's both just 8 moles. Okay, so times 8. Okay, so we're looking at 761.68 grams. 0.68. Okay, questions on the first one? How many people have done the second one? Okay, I'll give you a little bit more time. Go back to those. Okay, what type is the second one? Type 4. Okay, it gives us the number of molecules and asks for mass. Okay, guys, and remember, I'm never going to ask you what type is this on the test. I'm just saying that so that you're kind of getting the patterns. You can identify it and know what pattern is what. Okay, so we know that we are looking for little m. We know we have the number of molecules, okay, at 1.2 times 10 to the 25. Okay, and anytime we see number of molecules either given or requested, we know that this number is going to play a part. Okay, they also tell us that this stuff is iron 2 nitrate. So Fe with the 2+ charge, nitrate with a -1 charge, gonna look like this. Okay, so getting the molar mass of that, 55.85. That's our 1 iron. How many nitrogen are there?
2.
2. Okay, so 14.01 times 2. And how many oxygen? 6. Okay. So 55.85 plus 28.02. That's our 2 nitrogens. Okay, plus 16 times 6. All right, 179.87 grams per mole. Okay, if I'm going to get mass, I need N. I need the number of moles. Since I have the number of molecules and the number of molecules in 1 mole, what do I do with those two numbers? I divide them. Okay, number of moles is going to be a small number. Okay, so 1.2 times 10 to the 25 divided by 6.02 times 10 to the 23. All right, so brackets, 1.2 E25 divided by 6.02 E23. All right, so we are looking at 19.93 moles. Now, do I keep all the numbers in my calculator until the very end? Only ever round your final answer. Don't round anything else. Keep all the decimals. Okay? All right, so now that I have n and big M, I can get little m. N equals little m over big M. Okay, as always, we multiply both sides by big M, and we're looking for little m. So 179.87 grams per mole times 19.93 with all the decimals that are in my calculator, okay, moles. So the moles will cancel and I'll be left with grams. Okay, 3,585.45. Grams would be my final answer there. Okay, type 4, they're the most work. Okay, they definitely have the most to do. All right, how many people have done the third one? All right, I'll put the third one back up and give you a couple more minutes on that. All right, so for number 3, how many molecules of sodium sulfide are in 200 grams? Type 3 question. They're asking for the number of molecules. Okay, so since molecules are mentioned, 6.02 times 10 to the 23 is going to come into play. All right, so we're looking for the number of molecules. Okay, and we know it's sodium sulfide. So Na plus 1, sulfur minus 2, so Na2S. All right, so that's going to be 22.99 times 2 plus 32.07. Okay, so 22.99 times 2 plus 32.07. Our molar mass is 78.05 grams per mole. Okay, and they also tell us that we have 200 grams. Okay, what can I find right now with little m and big M? N, yeah, so that's what I should do first. Okay, I should just plug directly into the mole equation the two numbers that I have. 200 grams divided by 78.05 grams per mole. Grams will cancel, I'll be left with moles. Okay, so we have 2.56 moles, but I'm going to keep all those decimals in my calculator. 2.56 moles. Okay, what do I do with that number and Avogadro's number? I multiply, right. I'm looking for a big number. Number of molecules is going to be a big number. So, number of molecules, okay, is going to be the 2.56 with all of the decimals that are in my calculator times 6.02 times 10 to the 23. Okay, so times in bracket 6.02 E23. All right, so we got 1.54 times 10 to the 24. Molecules. Okay, now I just want to illustrate something here, guys. Okay, if I round this off and I just go 2.56, okay, I get a different answer. Now, in this case, it didn't end up that once I rounded it was any different, but it does happen fairly often that I would get like 1.545, and I would round up to 1.55, and you get 1.543, and you leave it at 1.54. Now we have a different answer. Okay, so it's important to keep those decimals, right? Yeah, sure, the first two decimals were the same, and we're lucky their third decimal is a 1 versus a 2. There's not going to be a rounding change, but if you're unlucky and it's a 4 versus a 5, then you got a rounding change. Your answer is different than mine. Okay, so keep all the decimals all the way through. Okay, how many people have done the fourth one? Okay, well, let's look at the fourth one. Okay, number 4 is a type 1 question. Yeah. Okay. So how many moles are in 65 grams? So I'm looking for N because that's number of moles. Mass 65 grams. Okay, and we are dealing with water. All right, so that will be 1.01 times 2 plus 16, which is 18.02 grams per mole. Okay, so all we have to do is plug the numbers we were given directly into the mole equation, so the easiest kind. Okay, 65 grams divided by 18.02 grams per mole. Okay, grams will cancel. Okay, so 3.61 moles would be our final answer there. Okay. How are we feeling about mole equation? Okay. What's tomorrow's quiz on? Mole equation. Okay. So expect one of each type for tomorrow's quiz. Okay. I'd say that would be a reasonable thing to expect. Okay. And should you expect maybe one of each type on the unit exam? You may not have to expect it, but since you don't know, if I put less than 4 on there, you still don't know which 3 I'm putting on. You still have to know how to do all 4. Okay, so it's best to practice all 4 types and get them figured out. Okay, guys, I was thinking we were going to have more time and I was going to do the unit exam review, but we only have 20 minutes left and I can't get through the unit exam review in that amount of time. So I'm going to do the unit exam review on Monday. Okay, so I'll give you the whole big full spiel. Okay, here's what I need from you by Monday, since your exam is on Tuesday. Okay, you need to study over the weekend. Okay, look at that review package, do the activities in there. Maybe even by that time you've done the practice test. Maybe Sunday's a good day for that. Okay, Sunday, do the practice exam. That way, on Monday, you know what you need to ask about. Okay, because I'll go through a spiel that's, here's what's important in this unit, here's what's going to be on the test, here's how I'm going to ask this. I'll go through all of that on Monday, okay? And then it's questions from you. Like half the class can be your questions. So if you've done the practice exam, you've done the studying, and you're like, oh man, there's this one thing I'm just not getting, that's what you want to ask about on Monday. But you're not going to know that if you leave studying for this unit exam until Monday night. Don't do that, by the way, that's a terrible idea. Okay, there's too much for you to study to do it in one night. All right, you need to be doing a little bit each day for the next little while. Studying for tomorrow's quiz is also studying for the unit exam. Cool, it's always nice to get things to double up. All right, so study for tomorrow's quiz and you're studying for the unit exam. Mole equation is on there. Over the weekends, okay, Friday, Saturday, Sunday, don't spend the whole day, okay, because that would suck. Right, but spend some time. Take breaks, do other things, but definitely spend a good amount of time this weekend preparing for that test. It will pay off. Okay? If you wait till Monday night to study, that will not pay off. Well, it'll pay off, but in a bad way. Okay, I don't want that for you. All right, I'm going to throw a couple more mole equation questions on the board for you guys to try. We'll just look over any that give us trouble, and then tomorrow mole equation. On your exam on Tuesday, there are a few what we call numerical response questions. Okay? They work like a multiple choice question. They have a bubble sheet. Okay? Just like multiple choice questions do. Except instead of A, B, C, and D, they've got numbers. All right? So what you'll have is, for example, one of the things is balance this reaction. Okay? So there's blanks. Right? But you don't fill in the blanks on the sheet. You fill in the numbers on the numerical response sheet. So on the numerical response sheet, there'll be a top block that looks like this, okay, where you can write in. Let's say your balancing numbers were 2, 1, 2, 1. Okay, you would write 2, 1, 2, 1 up here, and then you would shade in, so you'd have like a 1 and a 2, okay, and a 3 and a 4. You'd have a bubble like that for all of them, and you would just bubble in 2, 1, 2, 1 on the bubble sheet. Okay? The other way the numerical response will work is I've got some questions and I've got a list of concepts. Okay? So there's a list of concepts numbered like 1 through 8. Okay? And it would be things like polar nature of water, solubility, okay, double replacement reactions. There'll be these different concepts. And then there'll be a question that talks about a situation. And it'll ask you, what 2 concepts are most mentioned in this question? and then you just fill in the numbers, okay? You'll have a numerical response thing that looks the same, but it'll only have two options. And you'd go, I think it was concepts 3 and 5. Do it in numerical order. Don't go 5, 3. Okay, 3, 5. So you'd shade in the 3, you'd shade in the 5. Okay? It probably sounds more complex than I make. It probably sounds more complex than it actually is. Okay? Once you see it, it'll make perfect sense. All right? Okay, go ahead. No, just stretch. All right. Good job today, guys. Be ready for your quiz tomorrow.